Okay, welcome back and good afternoon to you all. Okay, now what I want to do today is to continue to look at one or two things. Now, let me just look at it. What I want to do is to look at connecting instruments into a circuit. Now, let me repeat that connecting instruments into a circuit, okay, or circuits. How to connect an ammeter. How do we connect a voltmeter, for instance? Okay, how do we connect a voltmeter, for instance? How do we determine the current flowing in a circuit when we need to connect an amp meter to measure the current flowing? Um, for instance, how do we use a tongue tester, for instance, okay, which determines or could show you the voltage traveling through the cable at that point in time. So what I want to look at is getting and showing. Now again, you're not going to see what I'm doing on at this in this streaming. Okay, but what you need to look at again is you need to go to the video that says connecting instruments into circuits, and it is well titled. You cannot miss it. Okay, and I'm making sure that that everything is there for you to see. Now, let me just get to work on this, and let's start our session. It's always interesting how uh, okay, I'm not going to put you up with first. Let me just look at this initially. Okay, I think that should be it. Okay, right. So what I want to look at is sitting gills again, and we continue with that. And what I want to look at is session 6, connecting instruments into circuits. Okay. So at this aims and objectives of this session, you should be able to state how voltmeters and ammeters are connected into circuits in order to quantify circuit voltages, current, and resistance. Okay. Let's raise it up a little bit. Okay. Okay. Okay, that's what we've done already, and you'll find the videos covered a lot of this already previously. So look back at the previous videos. Don't just think you're going to look at one video and it's going to cover everything. That is not the case. This is done section by section by section. It is your responsibility to ensure that you look and read through the videos yourself. Okay? You can reply to my videos if you wish. Okay? Just let me know what you think. Okay? Or I have no problems with comments. Right, digital meters. Digital meters take an input signal and convert it to a series of pulses. Digital signals are either on or off. Advantages of digital meters: strong, no moving parts, accurate, easy to read. Disadvantages of digital meters: batteries need replacing regularly, not easy to tell if it is the meter or the circuit that is at fault. Readings may vary. And here we have an analog meter, okay? Let me just move in closely so we can see it, okay? Okay, pan back a bit, okay, so we can still get everything into view, okay, okay. Now, analog signals are variable, which means they are changing all the time, okay? So this is an analog meter. You have your former, you have your control spring, which allows the meter to rotate and move backward and forward. You have your moving iron. You have your fixed iron, okay? Moving iron meter repulsion type, okay? So when these get too close together, one repels the other. A moving iron meter is based on the principle that when two magnetic fields oppose each other, they deflect or try to move in opposite directions. Okay. Moving iron meters. There are two types of moving iron meters: repulsion and attraction, which both work in a similar way. This type of meter is less commonly used now. Advantages: cheap, fairly robust, can be used on AC and DC. Disadvantages: uneven scale, can be affected by heat, can be affected by stray magnetic fields, only accurate at the lower end of the scale. Moving coil meter, okay. Let me just go in so you can see it in full, okay. Turn back a bit. Okay. Moving coil meter. Now, a coil is wound on an aluminium frame. It is supported via a spindle resting in a jeweled bearings, which enable it to move freely. And here you are, soft iron core. You have your control spring. You have your coil. You have your aluminium former, permanent magnets, and you have your terminals. Okay, positive and negative, and that's your scale. Now, moving coil meter, this meter is much easier to read because the scale is linear, meaning the accuracy is constant. Even scale accurate, unaffected by stray magnetic fields. Disadvantage is fragile, expensive, only measures DC. Okay? Ammeter. Okay? Now, ammeters measure current. In a circuit, it is critically important that the ammeter is placed in the correct position. Multimeter set to read current. In a series circuit, the current is constant throughout the circuit. The ammeter is connected in series with the load, and we will assume that the instrument has a resistance, and so there will be a volt drop when the current flows. Okay. Now that's taken into account in the matter of shunt resistance. And that simply means that it puts resistors in place to assist in measuring the current accurately. Okay, but do a little bit of work on that for yourselves. Look at the meters that you may be using, whether you're at college or otherwise. Increasing the range of the meter. If we want to increase the range of the instrument, which is sometimes necessary as the current can destroy the sensitive coil in an analog meter, we have to place a resistor in parallel with the meter. Okay, that is what I was just mentioning. Okay, this resistor has a very low value and it's called a shunt. Okay, and here we are. This is our shunt resistor across the meter. It's to make sure that the meter does not take on too much current, causing it a problem. And you will notice that the resistors, the meter, the shunt is in parallel with the meter itself. So that will make sure that the resistance is quite low in respect of the load. Okay. We have in effect two resistors in parallel connected to a resistor, the load that is in series with them. Okay. So you can almost say you have a series parallel network in this case, but make sure that you understand the concepts and do a little bit of groundwork for yourselves. Okay. Again, be sure that you're using the meters correctly and that you know how to read it precisely. Okay. Voltmeters have to be connected across the voltage, the load. The voltmeter is connected in parallel with the load. The same voltage is dropped across the load and the voltmeter. Okay, and that is all in what we're just showing you there. It's okay. Sorry, I was going to. A little sneeze came up on me then for a moment there, but it disappeared. Altering the range of the voltmeter. The problem with connecting a voltmeter into a circuit is that the current is supposed to flow through the load. What happens is that it splits up and some current passes through the voltmeter. The voltmeter needs to have a very high resistance, so reducing the current drawn to a negligible amount. To alter the range of the voltmeter, we must connect a resistor in series with the meter. This is called a multiplier. Okay? And here we have our resistor called a multiplier in regards to altering the voltage range. You've seen that we can alter the current range in regards to the meter using shunts. Here we alter the voltage range by using a multiplier. Okay, I hope you found this useful. Okay, and for now, have a good day. Bye bye. Okay, I hope you found that useful. So again, look at the actual video itself, and I'll get back to you shortly. Now, these videos are not being released just yet because it's a process of ongoing work, and you need to look at some of those videos I have released already so that you're better prepared when you come to these videos themselves and you have a better understanding. I've released a lot of work on series parallel circuits, so please utilize those information. Put pen to paper. Make sure you understand the concepts behind it. If not, look in the engineering mathematics book. Look at your electrical principles. Look at J.B. Pratley, electrical principles level 2 and level 3. Okay. Now, thank you for your time and have a good day. Bye bye.